No. Sharing content to this screen.
Oh, you want to
Sharing,
swap
yes,
to the screen?
yes.
Okay, I see.
Okay.
Yep.
Thanks much for bless you, choosing this course. Although probably it's not free choice, but mandatory. But I'm pleased to see you. Did Dr. Han tell you something, or he just distributed syllabus?
He didn't say
And you didn't ask him any questions? Okay. So you saved time. You saved his time. He saved your time.
That's right.
I'm not sure if I will do the same. Maybe it will be a little bit more. So those printouts, and I intend to bring more so that you take home. It is main form of your reporting that is being graded. So by the end of semester, you do little projects, prepare write-ups, same as here, and present them. And this is the main thing. And as we go, I will try to entertain you with some homeworks, but those are not substantial part of a grade. So more for me to see a feedback from you if you take the information well. So what's the name of the course? What is physical chemistry? To you, what are your expectations of physical chemistry?
Equations.
Okay, what else? I can satisfy this demand. Can you do physical chemistry without equations?
I don't think so.
Huh?
I don't think so.
Well, not academic, not for the in class for the grade, but if you are targeting academic career in research, is it possible to do physical chemistry without equations?
Do you have a computer doing for you?
Even without computer?
Maybe.
Huh?
Even without numbers.
Right. So how do you do physical chemistry without computers, without equations, without numbers? Huh? No.
Figures.
What?
Letters.
It's more like literature. But what is chemistry?
Study of atoms and molecules.
Okay, good. And how they break into pieces, more or combine together. But so one does synthesis by mixing some pleasantly or not pleasantly ordered liquids, and then you get some new substances. As soon as you have obtained a product of reaction, what do you do with it? Lift your hands if you're exposed to the research. 1, 2. If you have an idea what research is. Okay, good. So what do you do if you are like not physical chemist but chemical chemist? If you have a product of a reaction, what do you do next?
Figure out what it is.
Yes, figure out what it is. But what is a smart word? Yes, characterize. So in some sense, characterization is part of physical chemistry. So if you take your sample into a spectrophotometer or to NMR, other branches of chemistry, like analytical chemistry, can take this mind. I claim it's physical chemistry. We will not do experiments here in class, but understanding basics of how the instruments works and how you characterize molecules or maybe something, collections of molecules or how reactions are going, it is part of physical chemistry, so characterization. And you can do characterization without equations, without computers, and without, you just need instruments and chemicals, right? So practically, as soon as you have principles that you more or less understand, or even without understanding principles, to put sample into the instrument, you do not need much knowledge. But if you do, it is a plus. So we'll get some background for this kind of procedures. So chemistry is atoms and molecules, right? So atoms, what are atoms?
Building blocks, like,
Very versatile, but what are they, like blocks, square, rectangular, like masonry bricks? What is the shape of atoms?
they're changing.
Huh?
They kind of like,
But can you show by your hands how atoms look like? So you either draw flowers or you show spheres, right? That's good. So why are you showing flowers? Ah, so atom is not like a standalone thing. It is composed of something. So it's composed of what? Huh?
Electrons, protons, neutrons.
Good, good. And is electron a particle?
yes.
It's a provocative question. You do not need this class. You're already educated. So if it would be a particle, right? The word particle means that you can set it in a space. Tell here are coordinates of my particle. But if it is a wave, it's distributed everywhere, and it has a little more or a little less amplitude of a wave. And this feature of electrons, that they have weight in nature, makes physical chemistry into a special branch of science. If you recognize this and you seek consequences of wavy nature of electron onto characterization of chemicals, then you do not need this course. You can immediately go to start your research project, get a grade, and do not waste your time. So what I'm going to offer is just slowly but surely speak about wavy nature of electrons from different aspects. As some of you requested with equations. But again, this is not a key feature. You can be outstanding physical chemist with publishing papers and getting recognized in the community without writing equations. Those are auxiliary tools that give some concepts are not always possible to intuitively imagine for human brain. And equations are needed if something is a little more complicated than you can show with two hands. So it's only way to see unseeable things. Also, it's a little disclaimer before we start. So some of you may demand and request equations. Some of you may feel uncomfortable with that. So they are not meant. The equations math is a language of physical chemistry. So, and a lot of times we will do the following exercise, and I will forget to announce it, but we will do it all the time. We will translate observations or words into equations, or translate equations into words. So it's nothing but one more language. And being like, if I do not know Spanish, it doesn't mean that I'm poor in physical chemistry. Same, if I do not know math, it doesn't immediately mean that I'm poor in physical chemistry. It's one of the languages that makes it a little more complicated. So do not fear if you see them. Stop me. I'll be happy to bring some basics from calculus if it was a long time ago for you. It was a long time ago for me as well, but I'm trying to refresh it from time to time. Okay, so positively charged ions, negatively charged electrons. Electrons have wavy nature, and wavy nature is a challenge for human brain. And we are coming to the idea that from time to time we need math. So if you connect all the things together, it means that we need an equation that describes wavy nature, equation for wave. Who can write an equation for a wave, for any wave? Or has an approximate vision how it should look like? Yeah, there should be time.
Oh, sign.
Sine. Sine, okay. Sine of what? Or something.
Something, yeah.
Okay, okay. So we are considering waves. And if I will stay alive and healthy for the next 35 minutes, we will depart in peace with knowledge of the wave equation. If you do not come into big conflict and everything will go smooth. So what do you want to, no, some people do not want to do anything in physical things, but if one is interested to pursue this path, how the equation for wave should look like? What do you expect before we start? Pattern, yes. Huh?
Gradual.
Gradual means it's not in a single point, but it's in different spaces, right? So it should be the equations exist in order for humans to solve it. Maybe computers, maybe some other things, right? So what is the solution of the wave equation? I believe if we discuss things ahead, the math part will be less boring and easier to digest. So we need to define the nature of a wave. And for electrons, we need to discuss what is waving, right? But wave equation is kind of very nature of thing, and we can which waves do you know in your regular life? Which waves do you see? Light?
We don't see it, but
Yeah, you do not see that it is wave, you know that it is wave. But which objects you see for sure that they are wave?
water.
Yeah, it's the best example. And how does it look?
Oh.
Yeah, but go ahead, you can show.
Oh, when you just sort of walk in a flat water.
So the height, the surface
Yeah, it's strange.
along like changes the height.
The height is
In one point it is in one point of space it is higher, in another point of space it is lower.
Yeah.
And the positions of this like peaks and dips are changing in time. Okay?
Yeah.
So like you can tell that it is some in for water it is height of a surface in comparison to like zero level. What other examples you can give? I should sand, yes, and it is more static. I always forget to do it, but if you take a long rope, or if you walk in a garden, there is a chain, and you disturb it, and the wave starts going along the string. So it's very visible by human eye. And if you play any string instrument, it's not very visible but by human eye, but also it's waves traveling, reflecting, going back or good. So wave is a field. It's like dependence of some variable, like height, deviation from average value, as function of position and time, right? Something is changing. And this wave is a solution of wave equation. Right? But we do need an equation that will generate waves. And eventually, we need to build this equation in such a way that waves generated by equation will reproduce what we see in nature. Okay? So Alyssa was showing like petals. And from the freshman chemistry, you probably, or from high school, like S, P, D orbitals. Okay? So electrons, probability waves. There are areas where they have high probability, areas where they have less probability. So that's standing waves. So either probability of being present or deviation from average level, or in light, it will be like strength of electric field. That also changes in amplitude and travels. Which equations, which class of equations generate wavy solutions? Typically, like if we are in primary school, we solve equation like 5 times x equals 10, right? And you get x equals to solution. Solution is one number. It's not a wave. For a wave, you need a lot of numbers, infinite number of numbers. So it should be something different. It should be not simply algebraic. Huh? Yes. Yes, we need trigonometry. And I will refer to a Wikipedia article on trigonometric functions in a few minutes. You can succeed in course without trigonometry, but if you refresh it in your head, you likely will be a little easier. But trigonometry is more about how the solutions look like, how the wave that is being generated looks like. But which equations generate wavy solutions? No, wave functions are solutions, but there should be an equation that generates wave function. So please list me courses in math that you are taking. Just give us different titles of the courses. Calc 3. Huh? Yes. So which equations generate wavy solutions? Differential equations. Okay. So we need today we need trigonometry and very basics of differential equations. So in narrow sense, in very narrow sense, do not tell it in public. Physical chemistry is applications of differential equations. You apply if you are taking differential equations to objects related to chemistry. Good. So if you who took or is taking differential equations now? I'm good. And you may consider to take it in the future. Consider this fun. Later on, I have a plan to get acquainted and learn your names, but if I start asking right now, I will not recall it. Maybe at the time of the first homework or first presentation. Oh, but I want to know something about your schedules. I know that I'm limited and I'm expected to entertain you no longer than 50 minutes, but how strict it is? Do you have, any of you have classes strict at noon or? Okay, yeah, I'll keep it easy. Okay, start, set, go. So at the last page of the booklet and in the materials distributed, you'll see list of lectures. They slightly change from year to year, but they are, most of them are recorded, so you can watch them and save your time. And also, there is a link. Maybe it's not exactly this one, but I'll share it. So if you do not feel well, or you just don't feel enough energy to walk to class, you can watch it. You can comment. Your face will appear there, and you can interrupt and ask questions. So traveling wave and wave equation. So an example of a wave is this perturbation of level of water, or deviation of your string or rope from equilibrium position progresses forward, right? So if you have function, then after some time, it will be translated in space, but time should be in the argument of a function. So if you create some wavy object, and function this wave means it's infinite number of numbers, right? Some shape, and we are not specifying which one. It could be just one peak or something complicated, but the typically you can say it is a traveling wave if after some time, if you add time times factor to your position, it will be translation of the whole function. And it can translate either forward or backwards. This proportionality between time and space is built in. Good? Easy enough. Which function satisfy? You were prompting me. Which functions satisfy the condition of traveling wave? Which functions will reproduce itself if we translate it? So one of the very typical solution of the wave equation is trigonometric functions, right? So it's a periodic perturbation in space, and if you add constant shift to the argument, it will be the same shape, but shifted forward and backwards. So if we speak about like sines and cosines, how can we wrap our mind and wrap our tongue around it? Which words are needed to describe a sine and cosine wave?
Frequency.
Frequency, what else?
Amplitude.
Amplitude and phase. But you were telling about oscillations as function of time. And if you are speaking about oscillations in space, like sand waves that do not move, just drawn on a surface, it still can be peaks and dips, and you can set up, you can measure distance between peaks. How would you call this? Yes, wavelength. And it's common to call it with Greek thumbnail, right? And frequency is in inverse of period. So how long would it take for the wave to come to the same phase, the oscillation to come to the same phase? Make sense? So if the argument of sine or cosine changes by 1, function comes to its initial value, right? 1 times 2 pi. So if your position is shifted by lambda, then you have 2 pi times 1, and it comes to the same phase. And same with time. If we wait for time equal to the period, it comes to its initial phase. So traveling wave, you subtract position and time. Well, it would be, we're going to do 2 things, practically 2 things that will be take-home message. give me, I don't want you to disclose it in public, but give me a little sign if you ever did laundry yourself. Good. So give me a little sign if you ever put a cup with a drink. It doesn't need to be alcohol, any drink, on a laundry machine when it comes to the drying cycle, when it rotates with high frequency. Try it. It's not dangerous. And look on the surface. If you did it, what did you observe?
Basically, like created a wave in the center of the cup, which spin.
But does it move? So it doesn't move. The equation that we put here, it is a traveling wave, right? But there are two types of waves generally: traveling wave and standing wave. Like if it has nowhere to go, it is standing. And your flowers for electrons in atoms, those are like SPD electrons, those are standing waves. So if you are putting cups with drinks on your wash machine and someone asks you, what are you doing? I'm studying SPD electrons. It's my physical chemistry assignment for the Labor Day. So we will do two things. We will study how to convert traveling wave into standing wave, and we will use trigonometry for this. And second thing, we will not derive, but we will sketch a basic idea how to construct a differential equation that will give solutions like that. Okay? And stop me if I'm mumbling not in an understandable way, or it is too boring. You can either slow down or speed up, or skip something. So suppose two students not interesting, two faculty are running into each other and not stopping. What happens? They just get bruises because of colliding. So humans or cars, not good. What if you throw two rocks into water and generate two waves? Is there any damage to the wave? Well, they interfere, but they pass through each other and then propagate freely after. So if you look on the traces of the from wave 1 and wave 2, after they pass through, they're not changed. So one of the nature of waves, they are linear. So there is nothing wrong and nothing bad to set up a collision of waves. It will be not a collision, it will be just interference. Add them together. So what if we take one wave going forwards, another going backwards? So we use the same x over lambda time over t, here and there, here it goes plus, and here is minus, here is plus. So it means one wave is translating forwards, another is translating backwards.
Let's give it an interaction.
You cannot call it interact. They just being added together. They are superimposed. Well, when we will get to electrons, they will interact because they have like Coulomb propulsion. But there are a lot of waves that do not interact. Like waves on the surface of water or electromagnetic waves, they do not interact at all. They just pass through each other. And as a beginning, we consider non-interactive waves because we do one step per time. Otherwise, it will be too many. So just mathematically, two traveling waves are added together. What should we do? It's a little exercise. If you know how to do it, please solve it. Convert it from summation into product. Trigonometry. Give me a sign if you have an idea how to convert summation into product. How to what one can do with such trigonometric equations. you do not need to solve it. I will not call anyone to the board, but just general idea. You may seen it in high school. Like, one of the symbols can be alpha, another beta. Would you be challenged by if someone asks you to replace a sign of summation into something, into products of a single argument? You recognize it, right? Do you recall the equation, or you just generally remember that there is something?
Vaguely. All the equation, but I'm not sure I'd be able to say it.
I'll try my best to print these equations and distribute once. But if you can recall or find it in Wikipedia, it could be useful, just saving times. So what I'm, today there is no time because limit, but later on I'll show how to derive this equation. Like, I do not trust my memory. There is a way to, very elegant way to derive it. It's much easier than to look into Wikipedia. But for today, one can just look into Wikipedia for 3 volumetric identities, and it will show, do you see it, or is it too small? So cosine alpha plus beta, cosine alpha cosine beta minus sine alpha sine beta. So right now, have you been in circus? Or you know what circus is, and entertainment. I just do not know the English word, but there are special part of a program when a person throws objects into air, catches, and do several objects at the same time. Jungling, yes. So we are just jungling with equations right now. We are already done with scientific meaning. So we are jungling with sines and cosines, and we are looking into a way to process this cosine of summation. Right? So what would happen? Remember, a couple of slides ago, we had plus and minus as an argument between this. One alpha was position, beta was time, right? And once for wave going backwards, it was plus. For getting forward, it was minus. If you put minus sign here on the left, what would change on the right? Huh? Yes, perfect. You see why? So sine of cosine of negative, if you swap argument of cosine, it doesn't change. It is a symmetric function, even. And sine is odd, anti-symmetric. So if you swap sine of beta, the sine, I can pronounce it, sine of a sine. Will swap. Okay, so I'll probably exercise it myself just to check that I'm super lazy. I'm probably laziest of anyone in the class. So instead of cosine, I will write c. Instead of this 2 pi x over lambda, I will write alpha. So c alpha minus beta, c alpha plus beta. So when it was minus, it was cosine alpha cosine beta minus sine alpha sine beta. When it is we swap the sign, then it will be cosine alpha cosine beta plus sine alpha sine beta. Do you know how to add together big numbers if you do not have calculator? What's the name of the rule? You put them two numbers one under another and add together in each digit, and then you like roll over anything that is bigger than 10 into next digit, right? So one can practice, what's the name for this?
Long addition. Long addition.
Long addition. So one can do long addition for numbers, and one can do long addition for equations. Let's do long addition for these two equations. Let's just add together the two equations. Oh, it's it touches the screen. And I want to put a little plus sign. So then on the left we'll have cosine alpha plus beta plus cosine alpha minus beta. The stuff that we have here, right? And what do we have on the right?
Cosine alpha, cosine beta.
Right. So sines will subtract and cancel. Cosine alpha, cosine beta. So now let's look on it from physical chemistry point of view. Originally, we had two waves that propagate towards each other, running to each other. And as a result, let me return back to the 2 cosine 2 pi x lambda times cosine 2 pi time over tk. So instead of summation, we got a product. And how do we interpret it? So if we select any point of space, like x equals x naught, right? Then this we are looking on only one spot in space. And then we have oscillations. So the wave will go up and down with this period. If you fix time, it will be just a periodic wave. But the positions of maxima and minima of this wave will not change. So basically, when you add together two running waves, they will combine into standing waves, which means there will be nodal points and maxima or minima that go up and down. We are going through this little simple exercise because when we will get to actual electrons, it will be a little more complicated. So we better discuss it. Stop and ask questions, develop questions, maybe ask them later. Oh, okay, I did it last time as well. So and this how it will look like. So instead of two cosine waves running to each other, at one point of time it will be higher here, lower there, and as time passes by, those will just change phase, but 0 points will not move anymore. So it is what you see if you do your homework for Labor Day. Put glass with drink on a one-way facility. Same. Put 2 here. So one part can be, so it is spatial part, because it depends on space, not like extraterrestrial space, but like position. And another is time, temporal part. And they are kind of independent. They are just multiplied by each other, right? So we are done with mathematical experiment number 1. From now on, you are certified expert by converting traveling wave into standing wave. Okay. Now let's. 5 minutes is very generous. So now we need 5 minutes for differential equations. We need to compose an equation which will give this product as a solution. Okay? And we will do reverse engineering. As we see the final product, and now we will try to build the industrial facility that will generate. So So let's do mathematical experiment number 2. No, I'm going to answer. Sorry. We are going to take this function and practice just a couple of derivatives, first and second derivative, and see what happens. Okay? And you're welcome to go ahead and try it yourself. I will not do it better or quicker than you. So, if we are taking derivative over space, then the part that depends on time will not change. It will be the same, whatever, cosine 2 pi t lowercase over t capital. And the spatial part, we need to recall how to take derivative of cosine. So first, if you take derivative, then anything that was in the argument will go as a constant up front. And then if you take derivative of cosine, it turns into negative sign. Yeah, thank you for negative. That's good. Sine of 2 pi x over lambda. Do not literally copy because first I have ugly calligraphy, second this touch screen is not good. Now we need to practice second derivative. So if we take this expression and apply derivative once again, the temporal part will not change, right? Because we are taking derivative only over space. And when we apply one more derivative over space to the sine function, we will get 2 pi over lambda once again, which means that we have power 2 here. And what is the derivative of sine? Cosine. So minus stays here, and we get a sine of whatever we need there. So basically, we are getting minus 2 pi over lambda square of our original function. Is it beautiful? You just make two derivatives and you reconstruct back your original function. What if we practice the same thing with time derivative? So the spatial part doesn't change, and for the time part, we will get 2 pi over period and minus sign because it is we convert cosine into sine of whatever 2 pi over t. And when we do the second derivative, the spatial part is not changed, and here we multiply by minus 1, 2 pi over period squared, sine of whatever was the argument, and it will be minus 2 pi over t capital squared times original function. So no matter we take second derivative over space or second derivative over time, we come back to original function. Can we say that second derivative over time equals to the second derivative over space? With some proportionality factor, right? So congratulations, now you're certified experts on building differential equations that give wavy solutions. So this proportionality factor, like 2 pi t squared lambda over 2 pi squared, 2 pi will cancel, and it will be lambda squared over t squared. And distance over time is what? Velocity. How soon the wave passes the distance equal to the wavelength. So second derivative over space, second derivative over time of unknown function multiplied by velocity is the wave equation. So if you were carefully doing all homeworks in differential equations, you are able to solve this equation and reconstruct wavy solutions. Good? If you need to go, you're free to go. I will entertain you for a couple of minutes, but it will be more entertainment rather than core sense. You all have flat TVs. We all have flat TVs. But what was the TV before? Huh? Yeah, it was like glass tube, right? So with electron gun, and when electrons come to the screen, there is a scintillation, and then it converts electronic beam into light. And if one designs double slit, classically there should be nothing in between, only straight lines. But if one carefully does it in darkness, there will be signal in the center, because electrons are waves, they interfere, and there will be interference patterns. And I'm going to exit and then come back. And you'll see some moves. So we run this thing. So, what do we see? So you do see some central point and then some waves that go in a circle. Those are simplified connection between our principles of wavy motion and very first attempt to describe atoms in the nuclei. So if we accept an idea that electron is a wave, then by moving across it, like a snake that eats its own tail, it interferes with itself. And it can either move forward, move backwards, or form a standing wave. So depending on the how quick it moves or how close it is to the center, it will develop different number of fringes. And it is what Bohr model is. So forming standing waves on a linear motion on a circle, according to the principles that we already got. And it was one of the so if the angular momentum, if the pace of these revolutions is specific number, integer, then it will be good standing wave. But if one tries to do something fractional, then it will just look ugly. And all mathematicians know that correct solution must be beautiful. If something is ugly, it is wrong. So therefore, in Bohr theory, this angular momentum takes discrete values. So it was just a little illustration. Done. Thank you for time and effort. No homework. Just enjoy. Happy Labor Day, and see you on coming Wednesday.
I haven't seen this course in Blackboard.
Huh?
I haven't seen this course in Blackboard. So
I haven't set this course in Blackboard. There will be nothing in Blackboard. I will send things by email.
okay.
So do
So
not
you're
worry.
not going to use the Blackboard for
No, no. I hope you don't mind.
Yeah. This is nice.
And after each meeting, I will stay a little longer, just in case anyone develops questions.
Thank you.
Thank you. Thank you.
I think
Hi, Fatima. How are you?
Good, how are you?
Very good, thank you. So you've got some solutions for your situation? You've got some job
I got
from Yonki,
no from you.
from me?
Yeah,
How do you know?
I work with you.
But my grants didn't. I'm not aware of any grants passing through. Oh, okay.
You will manage something for me.
Huh?
You will manage something for me.
I will. Yes.
How so?
You can speed it up if you contribute effort towards writing grants. I'm doing it myself as well, but you can help if you. It's more important than papers. So, as soon as, yeah. Thank you much. Yeah. So you see that grants more important than papers. And, the success ratio is about 1 to 7, 1 to 10. So if we submit, like as a group, if we submit 5 papers per year, it's with 5 grants per year, it's not sufficient. It's increasing. I'm doing some efforts. I was speaking to program managers in the conference. If you focus your efforts towards it, you'll increase chances and shorten waiting time. So you do not like other opportunities here? They need you to stay in the lab, or you just think that it is easier to get a job after this year? Well, you don't need to answer.
I don't know, you know everything. I don't know anything, you know everything. What happened so far? I believe you know. You are just.
No, I was not talking to Yunki. I was talking only when he called me once. I gave her very strong support. I don't know. He should give you a position after that.
No, he's telling that Dimitri likes you.
But I've told that I don't have money. So like I really.
No, but people say that you have money.
They are no. They're lying. They're lying. They do not know the truth. Like I'm a bankrupt about money.
I don't know. I don't need that money that
Huh?
much.
So right now I'm going to conferences on my own. Like I'm not getting reimbursed. If one looks online, there is a grant for my name for the next 2 years, but I already spent all money ahead of time.
I don't know. Please do something for me.
I will try my
You
best.
need to start my parents. So I don't.
I'll
Like
try.
I still work. A little bit I left for the paper.
Mhm.
I worked almost and then I stopped. I had something. Just little bit rest. Like, and work eating water. And I can work whatever new model compound materials.
Mhm.
But you know how long I am unemployed now. So,
I know and I understand how important the situation is. I need grants as well.
you know, I never like to leave your group. So I never want to leave your group. I want it. But no, I know only in the future I have to leave at some point, but not at this moment.
Yeah, thank you. I'm very happy because I've invested a lot of time in your training, and you deserve substantial salary. It's not like if I could, I would arrange things at a level as you is getting to.
I don't need that much. It's okay. And like I know how much time I spent. Like probably in my PhD, if I would concentrate this much, maybe I could do like something very good in my PhD, right? Like after coming here in 2017 fall, right? Uh, so after talking with you, I was like working maybe 18 hours per day or whatever. I didn't sleep. I mean, maybe I sleep 3 hours or 4 hours. You know, when people are going to sleep, I started working at night. And 12 to 4, and then I maybe a little bit sleep, and my son had school from 8. I need to wake up and then start again.
Yeah, it's not good
So
for,
it was,
for health.
but at some point when then I reduced that amount, but I had to spend significant amount of time first 2 semesters because like I did DFT in my PhD, but not BUSC. BUSC was totally new for me. I did quantum espresso.
Oh, you know quantum espresso?
Yeah.
It's good to know.
Yeah, I know.
I do not know it. I do not like it, but you know it.
Because it is free.
I know. But
So Nuri bought a like kind of powerful computer for me, and I put up
for good.
like I was so sad to leave you, but I think Aaron was sad.